Class, count with me. Ready, set, go. This one has 3 terms. This is a trinomial, and this one is a quartic, or we just call it a polynomial. Okay? So, what does that mean? That means if it has 4 terms, you cannot use X box method of factor. But you can use the box. Now, I'm going to show you guys 2 methods, and you choose which one makes more sense to you, okay? So the first method, I'm going to call it 2 GCFs. If you like it, use it. Don't like it, don't use it. Okay, so I just rewrote the problem. And how this one works is pretty easy. You just look at the first 2, and you figure out the greatest common factor. What is that? X cubed. And then you figure out what's left. Minus 4, right? Because you can just distribute to check your answer, or multiply to check your answer. Okay? Then you do the same thing on the other side, but it actually gives you a clue what the answer is if you're doing this correctly. Your parentheses here will be the same. Class, what's the GCF? Now pay attention. If you distribute the x, I don't get a negative x squared, so someone just recognize it is a negative. Negative x times x gives you negative x squared. Negative x times negative 4 gives you positive 4x. And you'll notice our parentheses are the same. Okay, that's the first GCF. Here is the second GCF. Notice that my parentheses are exactly the same. And you need to write it once. Everyone say once. And then you're going to write everything that's not red. So that would be x cubed minus x. Now, you might be asking, how did I go from this step to this step? Well, I factored out an x minus 4. This might make sense to you in this explanation. To check your answer, you can distribute x red times x cubed gives you this. Red distributed to the negative x gives you this. In black here, I recognize it also has another GCF of an x. And then this x squared minus 1 is the same thing we did over here in orange. Right? We already know that the answer is going to be x plus 1, x minus 1. So this is what I have as my answer in the factored form. Okay? So that was 2 GCFs. GCF, GCF, this should be the same. That's the first one. And then the second GCF is taking out the red. And the rest of that is just regular factor. Okay? Now, today, most students picked this second method of factoring. I call it the box method. Why? Because there's a box. And this box is the same box that you've been using. So let me show it to you. And I noticed that when I write this 4-term polynomial, and I write it in a z, what letter, class? It just makes it a lot easier. So I'm going to write x to the 4th, negative 4x to the 3rd, negative x squared, and 4x. I'm on page 18. And you basically do the same thing. Class, what is the greatest common factor? X cubed. Greatest common factor? Greatest common factor? Okay, now pay attention. If I write x squared, that would be x squared times x to the third is x to the fourth? No, so in this case we're just taking out a common factor, that would be x. And greatest common factor? Now pay attention, it has a negative, right? Yeah. So is that for positive or negative? Yeah. Let's check our answer. X times x cubed is x to the fourth. Negative 4 times x cubed is negative 4x cubed. X times x is negative x squared. This one has to be negative then. And then negative x times negative 4 gives me positive 4x. And then you'll notice that using the box method, my answers are essentially the same. X minus 4. X cubed minus x. It's exactly the same, right? And then you would do the same thing. Take out a GCF. And then factor that one again. So it doesn't matter which method you use, you will get these four as your factors. Let's finish the problem. We're supposed to factor, we just did that, whether you use two GCFs or the box. Now we're going to use the factors to identify the zeros. Partner A, tell partner B, how do you find zeros from the green box? Peter, how do I identify the zeros from the green box? We're going to set them equal to 0. Let's do that. Peter, if I solve this, what do you get? So you add 4 to both sides. So x equals what number? Positive 4. We got an answer there, right? X equals 0. When you solve this one, Peter? Negative 1. And over here? Positive 1. So these turn out to be our dots, our zeros. Let's put them on our graph. So I have negative 1, 0, 1, and 4. Class, where are my arrows? Start where? Up. End where? Up. I know that because it's an even, like x squared. And then we just do our sketch. Remember, all of these binomials here are x to the first power. So the multiplicity is odd, which means it's shoot through. Shoot through, and then I gotta shoot through. Okay? So to review, I factored. You can either use two GCFs or the box. Identify the zeros by setting them equal to 0 like Peter did and solving. And then you're making your sketch with your zeros and then your end behavior.